Okay. I've got a couple of people who haven't checked in yet. Patricia, John, Akira, Jello, Andrew. Is Andrew here? Okay. John here? John Wynn, are you here? Jello's on duty, isn't he? Akira, are you signed in? Okay. John, did you sign in? Just did now? Okay. All right. Okay. Okay, go ahead and navigate to I already got you, Elijah. Let's go back to week 4. That was the last GitHub assignments. Okay, 4-5 is problematic right now. But what I want you to do, if you had an issue like some of you had sent a message saying you couldn't get 4-4 to work. So what I want you to do. Others have submitted 4-4 with no issue. So this is a good one to run this test fix on. So load 4-4 for me, everyone. And there's a few items that I want to show you on the page. When you load the GitHub page, if by any chance you run into an issue where, really? Oh, for crying out loud. I'll have to make sure I delete that part of the video. Doesn't matter because those authentication codes, they change so rapidly. But anyways. All right, so when this loads, what I've been told by Cengage is they've heard the complaints from everyone, not just Northern Marianas College, but other universities that are dealing with this issue, that they've actually expanded the server resources dedicated to GitHub that they're serving up. So supposedly it's going to run faster. And you can see it just takes a few minutes the first time, right? Are you that old, Bill? You remember dial-up?
I refuse that. That's private, static void.
Uh-huh. Okay. So you guys are familiar with these little things here. You can reset your exercise by clicking this. I don't recommend resetting. If you've already got code that you've typed, don't try to reset. But what you want to do is come up here to this code base area, and what was it? Cengage Oh, for crying out loud, what was the thing? Here it is. All right, let me go back. Click on this. Go to show and run commands. And then you want to let's see. Engage. What is it? Code base. Oh, for crying out loud, what is it called? Here you go. You've got full rebuild container and you've got rebuild container, okay? So what I want you to do, make sure I've got the right one. Yeah. What I want you to do is click on code spaces, rebuild container, okay? You can simplify this as well by typing code spaces rebuild. And for our purposes, we're only going to do just a rebuild of the container, okay? When you do that, it's going to say currently cached images will be preserved together with your code. Any current changes, your code space will be rebuilt using the working directory's dev container. All right, think of it this way. In Git, you go out and you download code and it brings it down to your local machine, right? In this instance, you have your code space, your account, right, in GitHub, and you've gone out to Cengage and you've grabbed their code and pulled it down to your GitHub repository, right? So if something is changed, like for example, Cengage has fixed something out in the source repository, but it's not in your GitHub repo, then rebuilding your code space will actually go out, grab the latest, and pull it back in, okay? We want that, especially if there's issues. So you'll go ahead and click rebuild, and I did this today with them, and it takes about 5 minutes, okay? And this is actually a whole lot quicker than mine today. Yeah, this was real quick. All right, so this is supposedly gone out and recaptured everything, okay? Now, if, for example, your companion doesn't load for some reason, okay, the other thing you can do is go over here to Cengage Companion. You can click Open Companion tab. So, for example, if I close it, I'm like, oh, crap, what do? I don't have Companion anywhere. Where do I get it? You come back down here to the Cengage icon. Does everyone see it? Okay, this is very important. Everyone look and pay attention. This is where you get the Cengage Companion. You click on it, Open Companion tab, okay? And that will reload it. If, for example, it's frozen, remember, go down to the Cengage icon, refresh Companion, okay? And it will go back and reload those instructions again, okay? All right, any questions? This is only if you happen to run into a problem with your code base. We know that 4.2 is not working. We know that 4.5 is not working. 4.4 was displaying some miscellaneous errors for some of you all. And this is where I just want you to go out and reload the container with the code, refresh it, okay? The last 2 weeks, last 2 weeks, I didn't assign anything from GitHub because I was very frustrated with them. So after my meeting I had with them yesterday morning and the talk I had with customer support today, Chapter 7, I've got 6 Cengage GitHub assignments, okay, that you guys are going to be doing. And if you happen to run into problems, just run through these steps again. Okay. Cherry, you had a question.
Did you record it, right?
It's recording right now.
Okay, that's good.
All right. Okay. Any other questions? All right.
Sorry, did they mention that they're gonna fix that 4.2 or 4.5?
Since I'm live recorded, I'd like to really complain about them. Take this opportunity to. Please like and subscribe, share. Okay. I'm very frustrated with the fact it's taken 2 weeks for developers to fix this issue, because it shouldn't take 2 weeks, especially during a live. This is what we consider a production environment. Okay, you students are learning. It means that their stuff needs to be together, and it's not. And I'm a little more hypercritical about production environments where the code is not. It bugs me. Elijah?
Hit them with that imaginary technique, like and subscribe.
Yeah. Okay. So this week we're looking at. This week we're going to be talking about specifically strings, substrings, methods, all of that kind of stuff. Okay. And if you go ahead and open up your Moodle course room, go to week 7. We're going to be talking specifically about the special nature of characters and strings and how we deal with them, okay? With that being said, go ahead and open up IntelliJ. Excuse me. Open up IntelliJ. And while IntelliJ is loading, let's go ahead and pull up the slide deck down here. Are you guys using the slides or the flashcards that are included? Okay. Wait a minute. While I'm here, just a reminder that this is due March 28th, Project 2. March 28th. Okay? And next week, please remind anyone who's not here right now, like Jello and Patricia and I don't know who else we're missing. But please remind them that next week we will not meet in person. Okay, I'll have content ready for you next week to get started on, but we will not meet in person. I've got a special meeting I have to go to next week and won't be available. Okay. All right. So that the project 2 is due on the 28th. All right. So you got your flashcards. Please take an opportunity to look through these. These will help you kind of burn these things in your memory a little bit. All right, so let's go ahead and take a look at the slides. This week's content is very, very light as far as on what you have to learn. But I would say that everything that you learn with strings are very important. It's one of the most consumed objects and types that you're going to use in programming. Okay. You're going to be doing things like parsing objects, parsing strings, concatenating strings, putting things together, trying to find a text within a string all throughout your programming careers. And so everything that you do here is kind of, it's important to know how to do. All right, so there's just 5 topics here. We're going to be looking at common data problems of strings, how to use the character class versus the char, okay? Declaring and comparing string objects, using string methods. There's a number of static string methods that are available for you to use off of all strings. Using StringBuilder and StringBuffer, which are really the way that you want to do any type of concatenation of characters and strings. You want to use StringBuilder and StringBuffer, but there's specific times to use those. All right, common data problems. So when you're manipulating characters and groups and characters, they provide some challenges, right? what are those challenges? Number one, the string class in itself it's special. Okay, it's special. It's like a primitive and it's like an object. What do I mean by that? Well, let's go to IntelliJ and just create a new project. We'll call it Chapter 7 Strings, or you could call it Yippity Doodah, whatever you want to call it. It's just a project name. And then once IntelliJ opens, go ahead and create a new class. And I'm just going to call it Chapter 7 Strings again, just so we have a class to work with for these examples. We'll do our public static void main method. And inside of this, let's just create a simple string. So we do this by saying the name of the string, the name of the data type, which is string, and then we're going to give it a variable name. I'm just going to call it name, and I'm going to type in a name. Now, this is one way to declare a string. It's oddly similar in that we can do int number equals a value, right? But the way you declare objects, when you're declaring an object, you often use this type of syntax. New string, and then of course the value that you're passing into the constructor. So with the string class itself, you can create strings in two different manners. You can use what's called a string literal, or you can create it through defining an object, a new object. And both of these techniques actually create a memory space where that string is located. The problem, though, when you do this, we often might look at this and say, okay, Boolean, let's say, flag equals, this is an assignment, not equivalency, okay?
Hold on. What does that say? It says original, right? The one that I'm
Don't worry about what IntelliJ has put in there. Just type in string with something in quotes. IntelliJ is trying to be helpful with you because original is the internal parameter name. And to prove that, you could click on this, go in and look at the string, and you'll see that the parameter name is original. So IntelliJ just takes that and presents it, says, hey, give me the parameter for original. Okay, that's all IntelliJ is doing. But in this instance, since you're copying me, just type new string, parenthesis, quotes, Michael, or your name. Okay? All right, back to this topic. I'm creating a Boolean flag now, and I'm saying that I'm going to say name is equivalent to name2. Now, when we look at this at first glance, we would say, yeah, both of these strings are identical. So flag should be true, right? Just like if we would say int number 2 equals 0. And if we do, if we take those and we do to print those out, we could say that flag is for Michael string. Okay? And if I do the other one, system out print line number is equivalent to number 2, number is for primitive int. Let's put this in parentheses real quick so it shields that. Come on, where are you at? Oh, that's driving me crazy. Why can't I grab it? Where's my crossbar? Do that. Okay. So, what do you think the value of this statement is going to be? Let's, by raised hands, how many of you think it's going to be true number is for primitive int? Raise your hand if you think that's going to be what it prints out. True number is for primitive int. What do you think? No one's wanting to raise their hand. All right, what about this one?
I say yes, 0.
System out print line flag plus Michael string. How many of you think that's going to be true? Okay, we got Akira who says it's true. Anybody else think it's true?
Wait, are we talking about what's going to print out?
Uh-huh. Yes. All right. Well, let's see what happens. Because this is the interesting thing about making comparisons with primitives versus strings. Notice that it says it's false. They're not the same. And some of you might be scratching your head going, but they are. I don't understand. And true number is, they're the same. These are the same. Number is equivalent to number 2, right? But why is this statement yielding false?
Oh, because our name is a string, and a string can't equal to an integer, which makes it false.
Well-
Which makes flag false.
Well, both of these are strings.
Oh, I thought it was number 2.
Both of these are strings.
Is it because of how we, I forgot the term, when we're making the new object?
It could be. You might be tempted to say that the difference is in the way that the object is declared, but just to prove that that's not the issue, we'll just delete this. And we'll do that, okay? And if I run it again, you're still going to see the same,
The equal is not working on mine.
yeah.
Equal is not working on mine.
Okay? So now Akira caught something there, and he's right. I got ahead of myself and quoted it wrong, but the explanation I want to give you is when you do a comparison like this, you're not comparing the value, you're comparing the memory location. Okay? So now these two are using a special location in memory. Anytime that you declare a string literal, this is the way this works, by the way. Anytime you declare a string literal, it puts all the characters in this massive bank of memory, and it just keeps adding them. And any character that is the same, it just creates a pointer to that location. So in this instance, both of these are string literals. And there's this bank of memory that's dedicated for all string literals, and no duplicates can exist. However, when I do, let's go back, but I'm going to keep it similar. I'm going to say string name3 equals new string this is no longer a string literal. Now I'm storing it as an object. And so when I do the comparison of name and name3, it'll be false. Okay? So the best way to think about it, let me walk over here to the whiteboard and just so you can kind of visualize this for a moment. There's a special place in memory for strings and if you have a string literal like my dog is red, it keeps that special place for all string literals, okay, in memory. Whereas when you use the new object, this is a different location, okay? That's important because with strings, anytime you use this, you're comparing location, not value. So here, in the instance over there, the reason why Michael and Michael are true is because it doesn't store duplicates of Michael. It says it already exists, so it creates a pointer to that location. And when you compare the value, it says, yep, they're true, because the location is the same. All right, that presents a bit of a question for us then. How do we then compare strings? Because I want to know whether the two values are the same, not whether they're in the same memory location. That's the most common usage, right? Well, with strings, the way we do that is simply by using one of the included methods. Okay, so we're going to take the name variable, and I'm going to say equals. And you might also notice some other methods here that are available. For example, you'll see equals and you'll see equals ignore case. Equals and equals ignore case do exactly what they suggest. So in this instance, let's make one change. Let's change name to have a lowercase m, just so we can see that these are now two different objects because they're not the same string anymore. If we run it, you're going to see that the value is false now because they're two different string literals. Okay, so when we compare them, if we say name equals name2, I'm just going to put this in a system out print line statement. Okay. When we compare name equals name2, look at what the values are again. Are these the same in value? What's different? Yeah, lowercase. And so if we run it, you'll see that it's going to say it's false, right? So the other way that we evaluate strings is we use the equals ignore case. And this is the number one way that you actually compare strings. Many times you won't know if a customer has inputted a name in all caps or all lowercase. You won't know if the customer how the person has done it, right? And so just so that we exclude capitalization, we'll use that equals ignore case. So when we run it again, I'm going to highlight this method real quick so we can see what it says. This is using equals ignore case. This is using equals. Okay, I'm going to take out these bottom two because let's clean up our code examples here to see them. So when you run it, you're going to see then using the equals, it's false because the spelling of the name is different, right? It's different. But let's test it now. Name with name3. Name3 has the same spelling. And so if we evaluate name and name3, we're going to see that it's true. Because now we're just comparing the value of the text in those locations. So these are the two biggest mistakes that a lot of developers make when it comes to string comparison. Okay? Any questions so far? Any questions? Okay. Let's go back to slide deck for a moment. So we can see then the use of the double equals operator is not comparing values but memory locations. And when they're string literals, if the string literal already exists and you're comparing the same string literal, it's going to be the same, right? Because the memory location is the same. Okay. All right, let's talk about the character class. So let's go back to IntelliJ just for a moment. And let's talk about the string. If you take your command and click, and I think on Windows it's control click, but if you do that, you're going to go into that class, okay? And we're looking for a char sequence or char array. Here we go. Strings are made up of an array of chars, okay? At their most basic level, that's what they are. Now this is important because when you think about strings being a sequence of chars, how do we reference a char versus a string? What's the general syntax we use? How do we reference a string literal versus a char literal? Huh? I thought you just said it, single colon. Yeah. So strings, you can see, use double colons, double quotes, right? And chars use single quote. So if we do something like this, name char array equals new char array, and how many characters I have in my name? 1, 2, 3, 4, 5, 6, 7. So we're going to say 7, and then if I have name char array position 0, that's going to be single quote M. These are how strings are actually, this is what strings are actually made up of. They're actually made up of a character array. Now there's two ways you can create characters. You can also create a character by saying character, okay, letter, And you could do this. Character is special just like the string. It's kind of what we call a wrapper class. Okay? So when we look at a character, we can use the letter, and we can see that there's various methods attached to it. We can see that we can convert it to a string. We can check the equivalency. We can check the char value, because character is an object, char is a primitive. Maybe we want the char value of that character. We could do that. We could do a compare to, where we're comparing objects. We can describe constable, which is a new one. I don't know that one. Those are the common methods. Now, this is kind of important when we're thinking about characters. So characters, they describe the single character instance in an array that will eventually become a string. And there are places where you would use a character to evaluate certain things in how you're in your programming. Okay. All right. So let's go on and talk about string builders and string buffers. String builders and string buffers. So let's say that I'm going to delete all of this out for a moment. Okay, just give ourselves some more room. Let's say that I'm going to have a scanner class. We'll call it input, new scanner, and this takes a system.in, do a system.print line, take out the please enter your first name. Okay, and I'll do string first name equals input next line. And let's do this again. Please enter your last name. Copy this. We'll assign this to last name. Next line. We'll copy this one more time. Please enter your hometown. String hometown, input next line. Now, let's say that I was capturing this information and I just want to spit it all out and print it. I have two ways I could do that. I could take each of these values and I could say, let's see, string final, or let's see, string complete info, and I could say first name plus space quotes plus last name plus space quotes plus hometown, right? That's a typical way we think about concatenating strings. The problem gets that when you do this with large amounts of information, that data begins to use up lots of memory. Okay? Uses up lots of memory in storage on your computer. The preferred way that you actually would concatenate things is either with the string buffer, and we'll just call it SB equals new, StringBuffer. And all you do is just say SB append, and you append the values. So because I know I've got this funky little character here, I could do something like this. I could say string space character equals that. And I could say first name append space character append last name append space character append hometown. And now I have all of this data succinctly put together in what's called a string buffer. It's more memory compliant. It's better to use. And then as far as outputting it, I would just say SB to string. And if we wanted to see what that is, we could have system out print line SB to string. Okay? So let's run the program real quick. Enter your first name, Michael. Enter your last name, Rogers. Enter your hometown. And that's the process. All right, so this is using the string buffer. Now the string buffer has some things that you need to keep in mind. So number one, if you try to pass a null into the argument of the constructor or a method, it's going to cause a null pointer exception. Okay, so meaning you can't do something like this. You can't say append null. That will throw an error. Okay, and in this instance, you can't do that anyways, because it gives you a runtime exception. But up here, you can't say this null. That will actually throw a null pointer exception when you try to run it. The other thing about the string buffer is you really don't want to use this in a say mutable. You don't want to use this when things are synchronized. Okay? So synchronization is this idea that let me go to the whiteboard to explain this. Let's think about a multi-user application. You log in, and you have user 1 who logs into an application. Okay. You have user 2 who logs into the application, and they're both inputting some data. This is where you have two choices. You have to create multiple threads to handle it. Otherwise, what will happen is user 2 will request data back, and it stands a chance that user 1's data is going to come back to user 2. So you have to think about the time and the place that you use a string buffer. That means that its usage has to be in a thread-safe operation. Otherwise, the better one to use is the StringBuilder. Okay? And StringBuilder is basically the same pattern. So if we go up and we look at it, we could basically replace StringBuffer with StringBuilder. The other benefit about StringBuilder, where is it at? Yeah, this one has no guarantee of synchronization. All right, let me back up so we get this straight. StringBuffer is what you use when you in a multiple user environment. So by default, StringBuffer is going to take up more memory. Okay, by default, it will take up more memory because it's keeping in mind keeping everything thread safe. If you don't need that for a part of your application, if you don't need the thread safety of that data object, then the better choice is the string builder because the string builder is actually less memory intensive. Okay? All right.
Sorry, so do we define space character or something other?
Right there.
Okay.
Yeah. Let me take out this one here so you can see it better. Okay? Now, you could see issues where StringBuffer could cause some memory constraints. So for example, if you threw this into a loop and you were trying to capture a bunch of data and you're saying, okay, loop through and append, loop through and append, loop through and append, loop through, you're going to use up a lot of memory for that operation, especially if you did it like 1,000 times or 2,000 times. Some people think that might be the better solution. But in that instance, it's better to use the string builder when you're going to loop through large amounts of iterations to concatenate data. Okay? All right. I've got 10 more minutes here, and then I'm going to have to check out. So let me make sure we've got everything we need to. All right. Other methods. In the character class, we have is uppercase, is to uppercase. Let's talk about what those are. So if I have, let's see here. Let's change this to a character. And we'll do single quote. Okay. You notice that I can append a space character with no problem inside the string builder because the string builder itself gives me the ability here to append ints, chars, floats, doubles, longs, right? I can append anything I want because it's all going to come out as string, right? But in the space character, we can also do things like this. We can say space character to... Am I doing that wrong? Space character. Is the textbook wrong? Yeah. Let me give an example with the string class so you can see this. It's better to do it with that for right now. So we have hometown. You could do is blank, is empty. Is blank and is empty may seem kind of like, why is there redundant methods here? Well, is blank is, one of these is checking for null and the other is checking to see if it's just empty. Okay? So if we look at is blank, we go into the method, it's going to see if the string contains only white space, right? Whereas hometown is empty, this is going to check to see if the length is 0, right? This means it's not, the memory, the value is created in memory, but there's no data assigned to it. White space is data. Nothing assigned is no data, right? You got to think about that mentally. I can allocate a place in memory that has white space, that's data. I can allocate a space in memory that has nothing in it, and there's no data. Okay? It's like the difference of you saying, I've got a box I'm putting in my room, and it's empty. There's no data in it. I got a box, I put it in my room, and I have a blank sheet of paper in it. That's still technically data. Okay? That's a good way to look at it. Other things you could do here, we could say hometown to uppercase. And you can actually set the locale, which is important. Locale is going to be the language set that you use. Okay? For most cases, when we take hometown, what we're going to typically do is we're going to convert this line of text that I input and make it all uppercase. If you're thinking about this in terms of your database, it's better to store all the data in your database in one case sequence instead of having your database do the extra step of doing the comparison of uppercase or lowercase. Okay, it'll save you time on your queries. So you're given the option here to convert the data on the fly. Okay. Similarly, we could set the locale, and you can see there's a lot of languages that are available. You could set the locale as Japanese. You could set it as Korean. You could set it Taiwanese, UK, and then if it's not listed by default in IntelliJ, you can do this locale of and type in the actual string locale name. You got to make sure it exists first by that name, and it'll look it up. Or you can use this language reference. Okay, that's really only important if you're using if your web app, if your application is going to have to be dealing with multiple language sets. Okay, so for example, Indiana State University, where I'm at, they have a locale set that allows for Chinese, Japanese, Spanish, French, and there's a couple others, but it is based on the student population. If they don't have any students that year that are of a particular locale, they don't load it into their database set, so it saves memory. Okay. You have other options here with your string method. You could do, you could compare the length. Okay. So for example, hometown length, it's not going to give me the Java doc, but you can here see it's going to give you the length as the number of Unicode code units. So however long that string is. One very popular one that I've used quite a bit is this one, substring. So let's say that I enter a set of characters for hometown, and I want the last two characters for whatever reason. So I could do this in any number of ways. I could say hometown length -2 hometown length. And now I've zipped to the end of the string. I've counted from the end of the string backwards to get these last two digits, right? So substring, what it does is it gives you the value that's at that location. Another useful one that is I've used quite a bit is the split. So let's say that you have a value that comes in and it is character delimited. like a CSV file. Okay? So you read the CSV file, you read line 1, and you say, I want you to split it by commas. And this will actually give you a string array, an array of those values. Okay. Let's go back over here for a second. There's a lot of other values you could use here, methods. For example, if you need to evaluate if something is a digit, you can do that with this method. You can determine if it's a letter. You can determine if the character is a letter or a digit, if it's white space, and all of that. These are also, the string class and the character class also has the ability to use regular expression. Are anyone familiar with regular expression? Okay. It's another set of programming skills that you guys will not have to learn in detail, but it's good to be familiar with regular expression. Is it 4:30? Yes, it is. I have to go. Okay. Guys, that's it for today. I can't answer any questions because I have to go